Welcome to Spring LIB.
Hello. Here we have to propose the mechanism of the reaction and propose the most probable product of the reaction between the given diene and hydrochloric acid. So first let's label all the carbons from 1 to 4 as shown on the screen. And now we have to decide whether the cation attack will happen. So we have basically we have four options. And let's determine which option will lead to the most stable carbocation. So if hydrogen attacks um, the first carbon, then we form the following product. So we form a secondary carbocation, which has one resonant form. Which is a tertiary cation. However, secondary carbocations are not as stable as tertiary. So then H plus might attack second carbon. So in this case, we form the following carbocation. We form a tertiary carbocation. But it doesn't have any resonant form. Therefore, most likely, it's not the case. And carbon attack will not happen this way. So then hydrogen might attack the third carbon. So in this scenario, we form also a tertiary cation. However, it doesn't have any resonant form. So again, it's not feasible. And the last option is when hydrogen attacks C4. So here we'll be forming the following product. So we form a tertiary cation, which is in equilibrium with another tertiary cation. So it means that this attack will lead to the most stable product, most stable intermediate. And now we have to decide where chlorine attack will happen. So we have two possible positions. First option when chlorine attacks to C3, and the second option is when chlorine attacks to C1. So I think that theoretically, chlorine addition to C1 is more feasible because if chlorine is added to C3, it undergoes steric repulsion from quite bulky dimethyl group. Therefore, we can conclude that the product of the reaction between the given diene and HCl is the following product. So it's basically this guy. So it's more likely it's 1,4 addition. With possibly some minimum with lower yield of 1,2 addition. So, and here we might speculate that this guy has a higher yield in comparison with this guy due to the steric hindrance. Okay, now the second question is why this compound, which is shown here, does not undergo Diels-Alder reaction. And basically the answer is because this diene is not conjugated. Therefore, like the Diels-Alder reaction requires a possible conjugation between two double bonds, as shown in the screen. But in the case of the given diene, this conjugation is impossible. So therefore, it doesn't undergo Diels-Alder reaction.